Hi everybody, Patrick here from EngineeringShock.com, Engineering Shock Electronics. This is project 14 for the Raspberry Pi without the Raspberry Pi, RPI to RPI for short, and this project is called Logging Temperature. Recording, here I am. Okay, so time, we've imported before, serial we always import. CSV allows for us to create CSV files and edit them. Date time will be used for time stamping. I'm not going to talk about this function because, again, it's just establishing communications with our microcontroller, our RPI and RPI, using the Python script. One thing I will mention is, even if you can't connect to the MCU, try closing Arduino. That might help. Either way, I'm making sure that I'm connected to COM10. That's the biggest reason why you won't be able to communicate with your RPI and RPI. This is the writer function. We'll get to that in a minute. Slicer we've done before. We're going to slice up some strings. We're going to use the write read function to read back data, and this is our main code. So start it off creating a variable x and set it to 0, and we'll run this loop over and over again. Set x to a string of value of 5, send it along in the write read function, and the return value will be returned in value. We've done the write read, so basically we're going to send over 5, which instructs the RPI and RPI to take a temperature sample and send it back. And we're going to concatenate two strings, our return value in quotes, plus the string version of the return value that we got from our write read. I don't think this is actually necessary. I think it comes back as a string, but oh well. And it comes back looking funny. And so what we need to do is send it to the slicer. So value equals slicer, and we're going to send along the string version of value. And we're going to return our edited version of value. So let's go up to slicer, read the values here. And we're going to remove any B's. If you look down here, we're going to remove this and replace it using the value.replace function with nothing. And we're going to remove single quotations with nothing. R and N, we're going to replace with nothing. This is all explained right here and right here. Read the comments. And we're going to replace any forward slashes with nothing, so it will be returned just a single value, an easy value that looks like this, 18.52. It'll be in it. So that's that. Write read, again, we send over x. We send over a value of x. We write it to the MCU, and we wait for a response, the response is placed in data. So after slicer, we'll print the new value. We'll concatenate these two strings. The first being, quote, new number after slicer function equals, and then the string version of the value, which has just been sliced up. And we're going to call the writer function to send over value, our new edited value. And in writer, we're going to create an output file and open this CSV file. This needs to be made in advance. You're going to need to create a path, and create in that path, say, I'm going to create it in C reports, logs. I'm going to create those folders, and then I'm going to open up a CSV file. I'm going to create a CSV file by opening it up in Excel, and I'm going to save it as a CSV file and name it database. A means append, meaning open it and edit it, and start on the new line. So again, if you want to go to a folder, any folder, and create a new CSV file, this is a good way to do it. Excel worksheet. Let's just call this database. We'll open it up. I'll save as. CSV comma delimited. And save. And there we go. So now we have it. You can also open up Excel. Dang it, that's not what I want. You can also open up Excel and create a new way here. Anyway, I'm prattling on. Just do as I said and create the right path. So it has to be, you have to make sure you get the path right. Make sure this is set to A, new line, and everything's commented here. So current time equals date time now. We've done that before. We're going to get our current time using the datetime function, place it in current time. We're going to remove a few elements from current time, namely the day and the year and the month. And we're just going to keep seconds, minutes, and hours. And then we're going to write, we're going to create the file to write to, and we're going to write on the next to the first line available, temperature in degrees C plus the value which we sent over up here, and time and current time, which is what we just created. And then we're going to close it. And we'll do that over and over and over again. Let's look at the Arduino code, and then we'll look at the CSV file. So I'm going to stop this. So the Arduino code, very simple. What you need to do for setup on the RPI no RPI is to put all your LCD jumpers in place. That you should be set up basically by default for all the projects. And that on the signal selection header, fourth from the right is labeled temp, which connects our MCP 97000 temperature sensor to analog pin A0. Make sure that jumper's in place. Now, the noise is that sensor I find is a bit noisy, and I think it's because I could have added more capacitance to it. So if you find that the temperature readings aren't that great, don't worry too much about it. So we're setting up our LCD, our backlight. We've done that before. Incoming byte, we've done all this before. Creating a float called average temp and a float called sensor temp. Float will allow for us to create numbers with decimal points. Int hold is 0. We'll in void setup. We'll set up the LCD, or we'll begin the LCD, clear the LCD, set up our backlight, turn the backlight on, print project 14 to the LCD. Wait a couple seconds. Set up serial communications between the PC and the RPI no RPI. Set A0 as an output. Oh, this is actually unnecessary. Don't worry about this. You can actually get rid of this if you want to. It doesn't matter. I was trying to experiment with the noise on the line. Either way, it's not going to hurt anything. So setting it as an output, then as an input, but you can really delete that. It's not necessary. So while we don't have anything from the PC, do nothing. Once we get something, read it, clear the LCD, print the incoming byte. If it equals 53, which is 5, which is 53 is the ASCII version of decimal 5, which we've covered many times before, then set average temp to 0. Grab 10 samples from the analog sensor in this for loop. Add them together, so sensor voltage equals analog read A0, which is our temperature sensor. Average temp equals average temp plus sensor voltage. So we're basically, every time we take a sample, we're adding this value to average temp, and we're waiting 1/1000th of a second, 1 millisecond. Once that's done, average temp equals average temp over 10, and that means that we're going to average out our samples. And then we're going to do some math here, which is the conversion for the MCP 9700. And you can read the comments here. We'll clear the LCD. We'll print the temperature to the, and then we'll print temp. We'll go to the second line of the LCD, print out our average temp value, send it over to the RPI no RPI, and wait 500 milliseconds before doing it all again. So let's have a look for my output file. C reports logs. Database. And as you can see, on different days I've been logging this depending on when you actually when you're using it. So I've got all these different values. That's logging. Logging the CSV files is great. You can pull data, you can write data, you can read data. Anyway, that's the project. Quite simple. If you get errors here, It's probably because of these things, the forward slashes. Just experiment with it, and Google is your best friend if you run into any problems. So thanks for watching this Project 14. Next up is our final project, so stay tuned.